In this video, we're going to look at a few cases of the ambiguous, a few situations with the ambiguous case. We're using the law of sine. Okay, so the first thing, they'll give you some information. I keep using A, B, and C, but it doesn't have to be A, B, and C. First thing I'm going to do is I'm going to draw a triangle. I don't really even care what it looks like. I'm going to label A, B, and C, and I'm going to notice that across from the A this is little a, that's 22. Across from the C, that's little c, that's 18. And angle C is 34. Okay, so you'll notice right here that I've got angle side side. I've got the bad word, or the bad word backwards, side side angle. So this tells me right away that it's the ambiguous case. And Miss Deloach was helping me out, so thank you, Miss Deloach. And she was pointing out that as soon as you recognize it's the ambiguous case and the angle they give you is acute, if the opposite side is smaller than the adjacent side, then you have 0 or 2 triangles. And so I've always just said, well, figure it out, solve the problem, and see what happens. But if this is helpful to you, you can say thank you to Mrs. Deloach. Okay, so let's look at this particular problem. We've got an acute angle. We've got angle side side. So far we have met the first 2 requirements. The third requirement said that the opposite side has to be less than the adjacent side. Okay, since the opposite is less than the adjacent, this will either have, using Miss Deloach's style, this either has 0 or 2 triangles. Okay, so let's get started and play with our numbers and see what happens. So here I have sine of 34 over, so it's sine of an angle over the side opposite it is equal to, well, we don't know A, sine of A opposite over the 22. So I have 22 sine of 34 over 18 is equal to sine of A. And here is where I have to open my cabinet, my drawer. You'll notice, I don't know what I've been doing on here, but, I've been doing arc length. I am in the wrong mode, so be careful. We're going to go back into the world of degrees. So set up, and I'm going to come down to degrees. Okay. They could give you these problems in radians, but they rarely do. So we've got 22 sine of 34 over 18. Okay, and this gives us a value, so we can find the inverse sine of that. I'm doing inverse sine of, the answer is down here, is this button. See how that works? And that gave me that this first value for A is approximately 43.114. We'll round to 3 decimals unless I tell you otherwise. But since this was the scenario that Miss Deloach said is either 0 or 2 triangles, the other, this is actually going to be, I'm going to call it A sub 1. Sorry. Okay, and so A sub 2 is the supplement of that. So I can find the supplement of that previous answer. And then I have A sub 2 is about 136.886. Okay? When they tell us, a lot of these, they'll tell us, solve the triangle, which means we've got 3 sides and 3 angles, and they want you to find everything. So we have now found another angle. So we have found that angle A right here is, well, A1 we said was 43.114. We said that, or it could be 136.886. Now, notice this isn't drawn to scale. I mean, that looks like an equilateral triangle. But what we get is, if you remember from the previous video, we either have an obtuse angle here, or we have the acute angle. So we've got, so here's that obtuse angle, here's the acute measure of that angle. So if A1 is 43, then what we know is we had a total of 180 degrees. We've already spent 34 of them on angle C. Sorry, my iPad is acting very strange. We'll see if this works. We've already spent 34 degrees here, and then now we know we're going to subtract out A1, and that's 43.114. So if we have A1, then B1 that corresponds with that would be about, oops, so sorry, about 102.886. And then we need to find what a B2 would be equal to. So we've got 146 degrees minus this one. Sorry. 146 came from the fact that there was 146 left over for these two. Then this other one we have to subtract 136.886. And that gives us that B2, big B2, is about 9.114, and these are degrees. Okay, at this point we still need to find, we have C, we need to find little b, and you could find that using the law of sine. I'm going to do it this time, but I might not do it again. So I have sine of big B over little b is equal to sine of, I don't care, let's use the c because it's a nice pretty number, sine of c over little c. So I'm on one of them I'm going to have to say sine of 102.886 over b is equal to sine of 34 over 18. Okay, I have b times sine of 34 equals 18 sine of 102.886. Divide. Okay, hang on. There we go. 18 sine of 102.886 divided by sine of 34. And so this is little b, oh, so sorry, I should have labeled this as little b1 because I was doing little b1. So this is little b1 that's approximately, right, because I used that with big B1, yes. 31.379, whatever my units are. Okay, I'm going to do two more examples because the ambiguous case can give us different things, but I'm going to stop it here.